Yes, so we just completed the 10th installment, if you will, of our high school research program, initially funded by NLSI, now funded through Survey. When I arrived at LPI 13 years ago, this is one of the first assignments I was getting was, hey, create this high school lunar research program from scratch, and we don't really have any info to give you. So 10 years later, well, 13 years later, I guess it's exceeded far beyond at least my expectations. And that's what I want to talk about today is an overview of the program and then look at some of the evaluation data that we have. So first, I just want to acknowledge Survey and of course NLSI before that for funding of the program all these years. David Kringfer is a big proponent of it and just education and outreach in general. Our advisors and judges who have participated in the program over the year, and of course students and teachers, because it wouldn't be a program without them. So the exploration of the moon and asteroids by secondary students takes place each year, basically over the school year. Students begin in the fall with about 6 weeks of an activity to help them get a foundation of lunar and asteroid science. They then spend time doing research with their own scientist advisor, planetary scientist advisor, authentic open inquiry research. I'll get to what that is in a second. They choose a moon or asteroid topic they choose what they want to do with the guidance from the advisor and teacher. And then at the end of the school year, they create a poster and an abstract, and they present to a panel of judges. And from those presentations, we select one team to fund to attend the Survey meeting in person. So why ExMASS? Well, for years, going on 40, if not more, there have been calls for in national education documents for more authentic research experiences in the K-12 classroom in the US. You can see the numerous documents there, and research, just educational research is showing the positive impacts that those type of experiences will have on students, in particular with their attitudes towards science. So in this context, when we say authentic research, we mean students are doing processes or they're modeling processes that professionals do in their work. Inquiry-based is hand in hand with that, but also that students are pursuing a topic of their interest and utilizing the knowledge that they have, which can be problematic, which I'll get to also. So the goals for ExMASS are simply to provide an opportunity for students to engage with multiple practices of science, foster positive student attitudes towards science, and enhance student lunar and asteroid science content knowledge. So the simple question is, are these goals being met? Are we doing this? So for our first goal, yeah. At the end of the school year, students take a survey where we basically ask them, based on indicators from the next generation science standards, check off, what did you do? Did you do this? Did you develop a model, mathematical? Did you communicate your research? Did you ask a question? And they go through and check off these indicators, and over 79% of students report using one or more. They don't all necessarily use every single one, just depends on what their research was, or maybe how they were involved in their team's research, but they're definitely checking off a lot of boxes. Attitudes towards science use a instrument that I actually developed 15 years ago in grad school, but we modified specifically for this program. 4 years ago, we published a paper showing that this survey is it's good. It works statistically. It does what it's supposed to do. It measured reliable. Sorry, it's reliable. And we also ran some t-test comparisons on pre-post of the survey and found statistically significant differences between pre and post in the positive direction in students' attitudes towards science. We ran that data again with 2 more years of survey data from the past 2 years. We ran it a few months ago. And again, we're still seeing statistically significant increases in positive attitudes towards science. And when we say attitudes, we mean not do they want to become a scientist, but that they see the value of science, that it's important, either in their daily life or just within society. So there's a bit of a content knowledge problem though. In the K-12 system in the US, public system anyway, lunar and asteroid science don't appear, and solar system science specifically in general does not appear in science standards. There's phases and tides. That's not lunar geology. It's not asteroid science. They do come in though with some information from them about the moon and asteroids through culture, though it's not exactly right usually. They have a lot of misconceptions. So they come into this program with at best little to no content knowledge, and at worst, some pretty bad misconceptions that we need to try to iron out before they get going. So we do that in the first 6 weeks with Moon and Asteroid 101. They go through a series of readings. They look at some imagery. They present some basically a photogeologic analysis of some lunar and asteroid images before they go on and do their research with their advisor and teacher. Okay, so are they learning anything? Yes, they are, in terms of lunar and asteroid science. So we give them a survey before they do the 101 exercises, and right after they do it, before they do their research. And our data is showing us that with a couple of exceptions that I can explain, their survey items, their scores on those survey items do increase from pre to post. And this quote from a student actually is pretty, I've seen that more than once coming from them in their exit surveys, is that they're like, oh yeah, I see the moon now, and I talk to people about it, where I couldn't do that before. Same thing with the asteroid content. We see gains across all survey items. So in conclusion, yes, we are meeting our 3 goals. And I want to emphasize that while students may decide from this program, if they weren't already before, to pursue science as a degree or as a career, it is just as satisfactory for us that they come out with more positive attitudes towards it and see the value in it, even if they don't want to become a scientist. So big thank you. This is everybody who's ever been an advisor, and a lot of them have also been judges. Sometimes they're judges and then decide they want to be advisors. Had a couple go the other way, but this is everybody over 10 years that's volunteered to be an advisor, which is great. This is an example of the students of the work that they've done. 38 student posters, not counting the 3 that are here this week, have been presented at NLSI and Surrey meetings, and 8 have come away with student poster competition awards in that time. Published paper in Icarus, an Oregon team from a few years ago. Their data is now into the VestaTrek portal that Brian Day talked about earlier, the Trek portals. And a school from Wisconsin has participated in the past. They did some landing site analyses with Brian Day and Pascal Lee this past year, looking in Flawless Crater on the moon using the Moon Trek portal. So lots of things that they do even after the fact. And a former student from a few years ago is now an undergrad, University of Maryland. She was just published first author in a paper in the Astrophysical Journal. And this is a quote from her saying how the ExMASS experience really helped her with that and learning how to tackle something she'd never done before. Still looking for advisors for next year. So if you're interested, give me a shout. Be happy to have you. Thank you.
Thank you, Andy. You came in right at your 2-minute mark. So we have time for a question if anybody has one for Andy Shaner. I'll start with one from the chat from Ana Pires. Question to Andy regarding the content knowledge program. Should be also targeting teachers. Do teachers also need training in order to motivate students?
Okay, so that's a good question. No, advisors are very good for the content, for the expertise in the content and the process of science. Teachers, at least in our program, are really great about being able to help students manage their time. They know the students, they know who they are, and they help them and cheerlead them and get them and stay on task. We actually have it on our website. We've got a Venn diagram of what the advisor does and what the teacher does and how those two things overlap. So there's more information on our website about how that has all kind of come out in this program.
All right, thank you, Andy and Anna. And let's take one question in the room now and come back to further questions during the discussion.
Hi, Andy. Amanda Nam, NASA headquarters. I enjoyed my time when I was advising students for this, so thank you for the opportunity. I'm just curious. I noticed that you said about 80% said that they did, one of the science things. Do you have a sense of maybe what happened with the other 20%? Because it seemed like some of those were pretty basic, like even asking questions. Do you think that the students maybe didn't understand like what was being asked in the survey, or I'm just curious?
So that's a bad summary on my part.
Okay.
Some of those indicators, it's like 96%.
Okay.
Yeah, it could be that they just didn't understand or just kind of glazed over it. They could have. The problem is I wasn't really able. I'm not able to do any kind of analysis like that, trying to understand why they're answering the way they are.
Sure.
It's just not something I can do. And we just made this survey up because there wasn't anything out there similar.
Yeah, no, it's my guess that they probably actually all of them did it. It's just that it was I was just wondering if you had talked about it. So anyway, thank you.
All right, thanks so much, Andy. Thanks, everybody.